Hello everyone, welcome to my IB channel. We are specialized in IB programs, provide world-class tutoring service for IB physics and mathematics, especially MAA, Math Analysis and Approaches on both SL and HL curriculums. Today we are going to discuss the difference between functions and relations, how to differentiate, how to answer some questions regarding comparison or differentiating between functions and relations. Okay, so let's have a look first at the definition of a function. So a function by definition is a mathematical relationship between two sets or two variables. The first set is called the independent variable or the input, and sometimes we call it the argument of the function. And the second one is the dependent variable, which is y, or the output. So the first set is being mapped onto one and only one element of the second set. So when you look at this definition here, you have two key words here. The first keyword, that's every element of the first set. What does it mean? It means every element in the domain or in the input variable or the possible values of x has to have an image. I say it again. Every element, it means I cannot leave any element without an image, without a y value. So this is the first condition for a relation to be a function. The second condition, that is mapped onto one and only one. What does it mean? It means, for example, one here has an image A. Okay, so it has only one image. 2 has image is B, right? It's only one arrow coming from 2 to B, right? To letter B. And then 3 has one arrow coming to letter D. So that means this example here, is a function. Now, let's look at a couple of examples and you can tell me whether they are functions or just relations. So relations is just general category, right? While function is have to have the conditions, the two conditions. Okay, so let's have a look at this. Now we have 1, 2, and 3. We have A, B, C, and D, right? Now, when you look at this, the top example here, you can see, okay, the first condition is met. You have no elements has been left, so all elements have image. However, the second condition here is not met. Why? Because the element 2 has 2 images, which is not a function. Cannot be. Okay? So the top example here is not a function, it's just a relation. Now, the bottom one here, tell me, what do you think? Is it a function or relation? That's right, it's not a function. Why? Because there are 3 here. The element 3 has no image, has no y value, right? So again, the two conditions have to be met. The first condition, every single element of the domain has to have a y value. The second condition, it's only one arrow coming from x to y. Now let's look at this example here. And again, let's ask the same question. Is it a relation or a function? When I look at here, okay, the first condition is met. We have arrows coming from each element of x, and each element has only one image. Here it happened that element 2 has image letter B, while image of 3 has exactly the same. It's fine. It's fine. We call this many to one. Many to one function. And very popular example, basically the parabola or the quadratic function. So for example, this is the graph representing the parent function of f of x equal x squared. So when you look at, for example, when x equal 2, y equal 4, while when x is negative 2 is also 4. So is it a function? Yes, it is a function, but it's just a special type. It's called many to one function. Okay, sometimes we need to differentiate, or we need to identify whether from just looking at a certain curve or the curve of the function, whether it is a relation or a function. So in this case, we are going to apply the vertical line test. So the vertical line test, we basically what you do, you try to draw or sketch a vertical line passing through any part of the function. Any part. If this vertical line crosses the function at only one point, at any part of the curve, it means it is a function. If it crosses at more than one point, it is not a function, it is just a relation. For example, you look at part D here. If you sketch a vertical line, this is the pink one here, okay, it crosses the curve at 2 points, which means it is not a function, it is just a relation, right? When you look at part E, it's a circle, x squared plus y squared equal r squared, just general formula for circle equation. But anyway, so if I draw or sketch a vertical line, again, is going to cross the curve at 2 points, which means it is a relation. Okay, obviously B, C, F, and G, all of them are functions, because at any part of the function, the vertical line would cross only one point. Now, when you look at H here, is a little bit of an interesting example here, because we see some holes. When you see open circle in the curve, which means it's a hole, which means the function is not defined at this point, which means this point is not part of the domain of the function. Okay, so for example, when if I like to draw a vertical line here, actually this vertical line passes through only one point. Why? Because the second point down here is a hole. It is not in the function at all, so that's fine, right? If I draw a vertical line there, it's fine. It's only one point because the second point does not belong to the domain. However, when I draw a vertical line at the third step here, you know, it passes by 2 points anyway. So because they are solid points, they belong to the function. So in this case, part H or example H is not a function, it is just a relation. Okay, I hope now you can differentiate between a relation and a function. Remember the two conditions for a relation to be a function. The first condition, every single element has to have an image. The second condition, every element has only one image. Okay, so thanks for listening, and please, if you have any comments or questions, you can always write down in the video, and have a nice day.